Hi everyone, so I am just making a quick video to talk about the heat wave in the UK and to go over what I think is going to happen with the temperatures tomorrow. That's the 19th of July. We did not break the all-time high temperature record today, the 18th of July, but we will tomorrow, and it's so sort of certain that's going to happen that I'm not really going to sort of equivocate on that point. The temperature record is going to be broken tomorrow. The really only question is by how much. So the temperature record for the UK, the all-time highest temperature ever recorded in the UK was 38.7 degrees Celsius, which is I think 101 Fahrenheit, and that was happened during July 2019. Before that it was August 2003, which also saw a temperature of 38.5 I think. Now today we've seen 38.1, so just fell short of the record, but tomorrow we'll almost certainly break 40 degrees, and I'll go over whereabouts this is going to happen. So to start off with, I'm going to use the GFS for sort of some big picture analysis, and then kind of zoom into the UK. So you can see here we've got this sort of deep cold core upper low that's ahead of which there's been this high pressure area of high pressure that's been building for a while, and something called a plume, which is a region of hot air from this high that's been sort of building under this sort of strong area of high pressure, which you can see by these darker reds. So this is a sort of deep area of high pressure, this ridge, and this very warm air has been trapped in this area of high pressure, and this is deep warmth. So it's not just warmth at the surface, this is warmth that extends throughout the troposphere. And so what happens when the sun during the day heats the ground, where you get this thin layer of very warm air at the surface, that's called the boundary layer. Now when the air becomes very warm at the surface, it tends to mix with the air above it, which acts to somewhat limit the degree to which the air can become warm at the surface, which is where we are. But because the air is so warm above the surface at these higher levels, that allows the air to become much warmer than it otherwise would do, even in the strong July sunshine, and that allows us to see those extraordinary temperatures. So you can see that midday on Tuesday we have this ridge of high pressure just to the east of the UK, where all that warm air is. Now to the west, this cold core upper low is moving in, introducing cooler air from the Atlantic, and that's going to shut off the hot air. But before it does, it's very warm air to the east of higher ground will allow those exceptionally high temperatures tomorrow to happen. Now if we look at the 850 HPA temperature, and that just means the temperature at 850 millibars, about 85% of atmospheric pressure, so 1500 meters above the surface. This kind of gives you an indication of the air mass temperature. So you can see that tomorrow the warmest air again is to the east, and actually you can see it actually becomes briefly very warm just ahead of this front, because that air is trapped under this, again, very deep area of high pressure. Now these temperatures at the 850 hectopascal level gives an idea of how warm the air mass is. 24 is in of itself pretty close to a record. If we've seen higher than 24, then it's probably only happened once before, which had also been during that 2019 warm spell, although that happened under slightly different circumstances, which meant that we didn't get record temperatures. Well, we did, but I mean the temperatures are not going to be as high as they are now. But 24 degrees is exceptionally warm at that level, and you can actually use that temperature to estimate what it's going to be like at the surface by making some basic assumptions. Assumption 1, the air's dry, which it is, against the east of high ground. Assumption 2, there's not too much cloud to mitigate the effect of the heating. And when you make these basic assumptions, then the only thing that really determines how hot it gets is how high the ground is. You have something called the dry adiabatic lapse rate, which essentially tells you how the temperature varies with the pressure. The pressure is highest at the surface and then it decreases as you go up. So you can basically, the temperature is essentially a function of how warm the air mass is, which is again this 850 HPA temperature, and the pressure at the surface, which is going to be higher the lower down you are. So what that means is, assuming that this warmth is fairly homogeneous, which, I mean, again, you can see where it's warmest. The places that are going to see the highest temperatures are going to be are going to have the lowest altitude. They're going to be topographically low valleys away from high. But I mean, this is not unexpected, of course, but there are other meteorological situations where this doesn't matter as much, but because the air's dry and because there's not going to be that much influence from other factors, this becomes particularly important. So in this model, we can actually zoom into the UK. Again, this is just the GFS. I will be looking at the models in a sec. Let's see if we can do that. Yeah, we can. So let's look at middle of Tuesday. So temperatures are at the highest about 4 o'clock. This is French time. So 4 o'clock is kind of when this is based, because again, everything is moving to the east, so you might expect the temperatures to be a bit higher a bit later on, but because the cold front is moving in, it's going to be a bit earlier. Now, again, the air mass is fairly homogeneously warm above the surface, so and because it's so dry, there's not going to be a huge amount of variation in the warmth. So you can see there's these broad regions of very warm temperatures up to 40 degrees, and a few areas in Lincolnshire with 41 degrees. So the warmest parts, again, are basically the places that have the lowest altitude. So the Vale of York, around the Wash, East Midlands, very low-lying regions there, and also the centre of London, of course. The other factor is the influence of the sea. So obviously a sea breeze will act to cool anything down. So we can see on here, where's the surface wind? I can't find the surface wind, but there is the 850 wind, so we'll just use that. Be broadly similar anyway. Okay, so what direction of the wind is the wind coming from at around that time? So you can see, for example, in places like Kent, there's going to be, again, despite the high temperatures here, there's going to be breeze coming in off the sea. So, and again, this sort of peninsula here in Norfolk, though also slightly cooler. But then around the Wash, in this area where the air is coming directly off the continent and off the land, there's not really any North Sea influence. And again, also the Vale of York here, which again, the Vale of York in particular, actually, and down maybe into Lincolnshire, actually around this Humber region, that's where I would expect to see the highest temperatures. And again, it's what the GFS is showing. It's not necessarily what you might expect to see the hottest temperatures. You might expect it to be somewhere close to London, Cambridge, which is seeing the highest temperatures today, and it also saw the highest temperature in 2019. But well, again, I mean, if we no, actually, this one doesn't have 850 temperatures. And I'll just go back. because that is broadly true. But see this bubble of sort of warmer air in the sort of Yorkshire, Lincolnshire area. It's present in the southeastern parts as well. Actually, on previous models, this was even more visible. So I'll see if I can show you on this one. No, not so much. I think I need the hour by hour, which is not shown on. It's not shown on. So I'll try and show you what I mean, just so I'm being a bit consistent here. Okay, so let's get this up. Okay, so what I'm really referring to. You can see actually the highest 850 HPA temperatures are actually in this Yorkshire area, and in Kent as well. But again, the thing about Kent is we've got that sea breeze influence. And actually, if you look at the HD version of the temperatures, you can see it is that East Yorkshire, Humberside, Lincolnshire area that's actually seeing the highest temperatures, and I do think that is correct. On previous model runs, it actually showed it more, and this is something that I will need to emphasise, that individual model runs shouldn't be taken too seriously on an individual basis. It's what all the model runs are sort of showing combined. So you can see on this one, you can see that bubble of warmer air is actually more visible on this model run. So that's kind of where I think the warmest temperatures are going to be. So I'm going to look at some high resolution models and try and confirm that. So this is the 2 kilometre wharf. It'll be initialized by the GFS, so it'll show similar sorts of things, but actually you can kind of see this is warmest around there. See this little area of 41 degrees again is it's in the southern parts of the Vale of York, and also in inland parts of Lincolnshire. And again, this broad region of 40 degrees is in this very low-lying part of the East Midlands, northern parts of East Anglia, where the topography is very low lying. You can actually almost see where the Pennines are on this map, even before the front moves in. You can see the cool temperatures associated with the Pennines, but the hottest temperatures will be east of higher ground. If we look in southern parts, I mean London, don't get me wrong, London is warm as well, but it's a degree colder than this northern Lincolnshire Vale of York region. I think three reasons for that. Firstly, you can see the front is somewhat more advanced here. Cooler temperatures associated with the front moving in faster, so less time for the heat to build before the influence of the front starts to get going. Sea influence, I mean, it's closer to the coast. Well, I mean, maybe not, but the point is that the wind's coming from the south, so that there may still be some channel influence there. And like I say, also the air mass is slightly cooler. The warmest parts of the air mass are, again, maybe the far extreme southeast coast, but again, sea influence there, and also Yorkshire, Lincolnshire. If you zoom in, actually, use the row model. No, actually, I can't use that one because it hasn't finished running yet. But I can use this one, and can maybe hope to show some similar sort of pattern. These are all going to be slightly different because the models are going to show slightly different things. In fact, actually, this one is bringing in sort of somewhat cooler temperatures, and you can see that line of contours where the temperature declines very quickly. That's where the front's coming in. This one's showing actually slightly lower temperatures, only barely 40 degrees in parts of the East Midlands. This one actually has higher temperatures in the East Midlands rather than Lincolnshire and Yorkshire, which I think is because the front is a little bit more progressive. So they all show slightly different things, as they will do. So overall thoughts about this. Firstly, I'm inclined to believe that actually what I will do is some of these ensembles have just started running, so um, we'll have a look at a few different scenarios. So, for example, let's look at the London area. This is 850, but we can have a look at the 2 meter temperatures. So actually, let's put that in ascending order so we can see. So these aren't the maximum temperatures. This is just the temperature at 3 p.m. So they will be slightly higher than this, but you can see we do actually have quite a large range in the London area. Some more extreme examples up to 41 degrees, right down to 33, and the one that has 33 are less likely to happen, but again that'll be because the front's slightly more progressive. But you can see we have a substantial range, and again you can probably add maybe half a degree at least to these values, because this is not a maximum temperature, this is just temperature at 3 p.m. So if you add, like, say, half a degree, you've got a range here broadly from, well, up to 41.5 degrees at the most extreme, 40 degrees kind of medium value, barely 40 degrees, and then a handful of values that are a lot below that because the front is more advanced. And let's look at a sort of East Midlands near the wash type scenario for the same thing. Again, somewhat similar to the London one. Front slightly less progressive. Well, the front is less likely to be progressive further north, so broadly slightly fewer colder solutions, but again, similar kind of thing. And then finally, roughly around here, which I think is where personally I think the warmest temperatures are going to be. Maybe reflected on this, and yes, you can see clearly immediately much warmer temperatures here. And again, you can probably add a half degree to these values, so going up even towards 42 on some of these versions. So, and actually, I probably think we will kind of get up to these sorts of values in that part of the country. So, to kind of summarise, and I'll kind of might use this map as a prop here. The whole of England is, and the whole of the UK to some degree is going to be warm, but the most interesting thing I think is that we will break the record tomorrow of 38.7 degrees set in 2019. I think the chance of us seeing 40 degrees is very high, and again it will be in this strip of sort of London, barely 40 degrees I'm thinking, northern parts of East Anglia and the East Midlands I think more comfortably 40 degrees, and then this little strip from up the Vale of York into Lincolnshire, this would be, I think, more definitively above 40 degrees, and I think actually we'll see 41 here. So sort of places around the Humber, away from the coast, 41, maybe even 42. This one, the reason I'm going for values that are a degree or two higher than what we're seeing here is because this particular one represents a little bit of a downgrade on the heat compared to previous ones. So this one is somewhat of an anomaly. These more recent runs that will run from 6 p.m. onwards today, and actually what I think is taking everything together in aggregate. I'm not going to dismiss what I'm seeing here, but I think in parts of Lincolnshire and the Vale of York we are going to see 41 tomorrow rather than 40. I think London may well just scrape 40, North London especially. as will parts of the East Midlands and East Anglia. But I think large parts of Lincolnshire and the Vale of York will see 41. And 42 is possible, but I'm not going to bet on it and the reason for that is because these are the official Met Office stations. So this is where records can be broken. So that you can see there's large parts of empty space where you can't see records. I mean, luckily, there's quite a lot of observations in these areas that are typically archetypal record breakers in the UK. But in my opinion, the warmest part of the UK tomorrow, as I say, is going to be this Lincolnshire Vale of York area. And actually, this map's pretty good because you can actually see the orography to some degree. So southern parts of the Vale of York, Selby, Goole, Doncaster, potentially, maybe just slightly out of the warmest parts. Scunthorpe, I think, particularly. And actually, I think this weather station here, I don't know where this place is. The first time I heard of this station was today when I was looking through it. But I think this station here has perhaps the best chance of the highest temperature. I think this is going to broadly be where the warmest weather is. But any station around here, I think, has potential of seeing the warmest temperatures. Doncaster definitely could. Gringley on the hill. If this indeed is on a hill, then well, actually elevation 68 meters, so maybe not. But see, I think most of these will probably see definitely 40, but maybe even 41. This one again, 41 maybe. I mean, I wouldn't be surprised if this one here, Normanby, sees 42. But yeah, sort of around Lincoln as well. Lincoln could be a good place to see 41. Maybe, I think places like Peterborough more likely to see 39. Bedford maybe 39, and then maybe Luton might be the area that gets 40. I think most of London will stay below 40 tomorrow. Maybe I'm thinking maybe 39, but one or two of these stations I think will get to 40, and I think most of these areas around, I think Cambridge, for example, I think that will be 39 rather than 40. But I think large parts of this kind of area, Peterborough might be just be around 40. But yeah, Scunthorpe 41, maybe even 42. So implications, just briefly before I finish for the night. So the record is going to fall, there's no doubt about that. We only have to get to 38.8 in order to break the record, 38.7 to tie it. That's going to happen. In fact, it will happen across broad parts of the country. I mean, kind of everywhere from sort of Norwich, down into parts of Kent, as far west as potentially, maybe even as far west as Birmingham, Nottingham. Even somewhere like Manchester has a chance of seeing those values tomorrow, at least before the front moves in. And for places sort of to the west of the Pennines, to the west of higher ground, you're more likely to see these exceptionally high temperatures maybe midday, because during the afternoon the influence of the Atlantic air will move in. Loads of places are going to break the record tomorrow for England, and like I say, there's this kind of area, Vale of York, Lincolnshire, are going to see 40 degrees, with 41 and possibly 42 at a stretch up for grabs. So with the record being 38.7, then we're looking at the record being broken by 3 degrees, potentially 4 degrees, and some of you might draw analogies with the Canadian heatwave. I think it's going to be somewhat less extreme as an objective measure compared to the Canadian event, and just in terms of how difficult it is to get values above records. I think getting getting nearly 50 degrees is somewhat more impressive on a 5-degree anomaly compared to getting 40 degrees on a 5-degree anomaly. Because when you get these really high temperatures, increasingly the difference between 50 and 51 is a lot more than the difference between 40 and 41, if that makes sense. I don't know how else to explain that, but when you get but there's sort of a limit, because you're increasingly having to heat larger and larger columns of atmosphere in order to get those higher temperatures. So by the time you get above 50 degrees, even a 1 degree difference is like a lot more unusual than you get a lot. What I'm trying to say is things are more variable at lower temperatures than they are at higher temperatures. So I think the Canadian record is somewhat more impressive than the British record is going to be. I mean, maybe we'll see 43, but I doubt that. I think 42 at a stretch, probably 41. So record probably being somewhere between 40.5 and 41.5. So again, that would be a sort of 2 or 3 degree leap past the record. But again, perhaps even more impressively is the fact that so many stations are going to break the record. Typically, every time you break a temperature record and a heat record in the UK, and again, that's happened a handful of times in my lifetime. I mean, 2019, and then before that, 2003. Every time you do it, you might have one weather station, maybe two weather stations that breaks the record, probably one. But we're going to get half a dozen, probably a dozen. You know, we might even get 20 weather stations that all break the record. So it is going to be quite spectacular. Does climate change help? It's difficult because I think you can say that the influence of a warmer world means that these plumes are going to be more intense. But also the synoptic irregularity of the events, like what truly makes this event special, is that you have to have a bunch of things that go right all at the same time. And just because you have a warmer world doesn't guarantee that happens. And the most difficult thing about linking extreme weather events to climate change is that sometimes you have counterintuitive effects. So you might have a warmer world, but in some cases that actually might decrease variability. I mean, it might increase variability as well. In the Arctic, it probably does increase variability, but in the mid-Atlantic Ocean, for example, it might actually have the opposite effect. So the part of the difficulty is it's easy to link the direct effect of the Earth system having more energy to warmer temperatures. That's one thing that you can quite easily do. But the more important thing in terms of extreme weather events is, does climate change make these synoptically unusual events more likely? And someone might know the answer to that question. It's certainly a question, an interesting question, and I haven't done enough research on it to comment about that. But what I will say is that it's certainly a lot more difficult to answer because I mean, because even if you say that climate change increases the variability, which it might do in the UK, does it increase the probability of this particular set of circumstances that creates this weather event? I think the answer is yes, partly because the ability for this plume to survive so far north is probably because the Mediterranean and the eastern extremities of the Atlantic Ocean are so warm, and climate change would have made that more likely, I'm pretty sure. What I'm less sure about is the actual development of this high pressure area in Europe that allows that warm air to be transported northwards. I'm not so sure about that side of things, and whether climate change makes that more likely. It might make it less likely. You know, you can have a bunch of factors, and you know, if 3 of them are more likely and 1 of them is less likely, then the net effect is still more likely. But there's always a danger in linking individual weather events to climate change, because at the end of the day, climate change is a statistical property. It means on average things are going to be warmer. It doesn't necessarily mean on average things are going to be more extreme. Just means that the mean is going to be higher. It doesn't mean that the variance is going to be higher, although it might do. So I'm sorry to be sort of so kind of hand waving about it, but it's complicated, basically. Now the easier thing I can say is, does climate change make warm records more likely to fall? And then that's an easier question to answer, because that, if we look at the probability of any given number of events happening, yes, it's more likely to happen in a warm world because the distribution has been shifted. So even if the variance has stayed the same, then because the mean's increased, then this is more likely to happen. What's difficult is talking about this specific synoptic circumstance and whether that's more likely to happen. That's more difficult to suggest. But yes, these sorts of things are more likely to happen in the future, probably. So it's also difficult to say, is this going to be a once-in-a-lifetime event? Because you always have to account for the changing climate in those sorts of predictions. I mean, I'd be tempted to say that yes, it's a once-in-a-lifetime event. But that being said, I would almost have more confidence in, for example, the 2010 extreme December event that happened 12 years ago, the very snowy, extraordinarily cold December of 2010. I don't think I will live to see another December as cold and as snowy as that, but I think I might live to see another 40-degree heat wave in the UK, but that's just a gut instinct. I might be wrong about that. Well, anyway, one thing I can say is that as extreme weather events go, this would definitely rank, certainly in the top 5 most extreme things I've seen in my lifetime in the UK. I've seen plenty of other interesting extreme things. I mean, last year I saw snow in May, and well, for me that was extreme because I'd never seen that before in my lifetime. But I think this is probably, for example, rarer than that. But anyway, it's an extraordinary weather event. We're going to see 40 degrees. As I'm recording this, this is actually going to be the warmest night that the UK has ever recorded as well. Some parts of the UK probably won't get below 25 degrees. That's also extraordinary. It's actually even more extraordinary in some ways because warm nights, the sort of synoptics to create warm nights usually involve quite humid, moist air and quite a lot of cloud cover sometimes as well, which is not actually what we're seeing. So the reason that we're seeing a warm night is just due to the extraordinarily hot body of air that lies above the surface in the higher atmosphere. So, and that record, I'm actually more confident about the Tuesday. I'm more confident about us seeing 40 degrees than I am about the nighttime record being broken, because nighttime temperature records are always extremely temperamental. You get one weather station that you think is going to break the record, but then suddenly it suddenly gets cold at 10 o'clock in the morning for some reason. These things happen. Things like urban heat islands and the precise direction that the wind is blowing, these things matter a lot more with nighttime heat events than they do during the day. So I'm actually less confident about that, even though the night's already happened. We've already, I mean, you're seeing the observations here, you're seeing 26, 27, 28 degrees. To break that record, we're only 23.8, I think. But I'm still less confident about it now, about tomorrow reaching 40 degrees, which is still 2 degrees above the record. Anyway, I've jabbered on enough now. I hope you enjoy the video if you're watching it, and take care, everyone. It's going to be very, very hot tomorrow. Thank you very much for watching.